So here we have a trigonometric function given by 1 minus cosine of x divided by x sine of x. So we have to find its limiting value when x approaches 0. Clearly, when we substitute for the value of 0, we have 1 minus cosine of 0, which is 1. So we have 0 in the numerator divided by 0 times sine 0, so that's a 0. So we have an indeterminate form of 0 over 0. So that means we need to simplify the given trigonometric function. So what we're going to do, we're going to substitute 1 minus cos x by, so we have limit x going to 0. So 1 minus cos x can be substituted with 2 times sine squared x over 2 divided by x times sine x. However, what we can do here, sine 2x is equals to 2 times sine x over sine x times cosine x. So if we consider the half angle, then sine of x will be equals to 2 times sine x over 2 times cosine x over 2. So we have 2 times sine x over 2 times cosine x over 2. Now we can cancel out 1 sine x over 2 from the numerator and sine x over 2 from the denominator. So that gives us, so 2 and 2 also gets cancelled. So we have limit x tends to 0. So we have sine x over 2 divided by cos x over 2. So that is going to simply give us tangent of x over 2 divided by x. Now we divide the denominator, which is x, by 2 and then multiply by half to take care of the extra 2 that we have divided. So that gives us half of limit x tending to 0, we have tangent of x over 2 divided by x over 2. So this by definition is 1, the limiting value of tangent. So what I mean is limit x tending to 0, tangent of x divided by x is equals to 1. So we have half multiplied to 1. So we have a limiting value for the given trigonometric function, which is half when x approaches 0. Let us do another problem. So here we have to determine the limiting value of the given trigonometric function. So let us begin by simplifying the given function. So we have limit x approaching 0. So 1 minus cosine of 2x can be replaced by 2 times sine squared x multiplied by sine 5x divided by x squared times sine 3x. So now we're going to do a little bit of arrangement here. So we have 2 times limit of x going to 0. So we have sine x over x multiplied by sine x over x. So we have sine 5x. So we're going to divide it by 5x and then multiply it by 5x. Then we have 1 over sine 3x, which we are going to multiply by 3x and divide by 3x. And then we apply the limits to each of the functions. So we have 5 of them. So here 5x over 3x, so the x and x gets cancelled out, leaving us with 5 over 3, the constant that gets multiplied to 2. So we have 10 over 3. So we have 10 over 3 times limit x tends to 0 sine x over x. So this is going to be one of the limit multiplied by limit x tends to 0 sine x over x times limit x tending to 0 sine 5x over 5x, and finally limit x tending to 0 3x over sine 3x. So the limiting value of each of the function are going to be 1. That leaves us with 10 over 3. Let us do another problem. So here we need to determine the limiting value of the given function when x approaches 0. So here we have a sine 3x in the numerator. So we know the sine of 3x is given by 3 sine x minus 4 sine cube x. So we are going to substitute this value into our function. So we have limit x tends to 0, 3 sine x minus, so we have 3 sine x, then minus of negative 4 sine cube x will be plus 4 sine cubed x divided by x cubed. So the 3 sine x and negative 3 sine x gets cancelled, leaving us with 4, which is a constant, times the limit x tending to 0, sine cube x over x cubed. And this, by definition of the limiting value of sine x over x when x tends to 0 is going to be 1. So we have 4 as the limiting value of the given trigonometric function when x approaches 0. Let us do another problem. So here we have another trigonometric function, 5x plus 4 sine 3x divided by 4 sine 2x plus 7x. So we have to find its limiting value when x approaches 0. So let us begin by dividing the numerator and the denominator by x. So we have limit x approaching 0, 5x over x is 5, plus 4 times sine 3x over x whole divided by 4 times sine 2x over x plus 7x over x is simply going to give us 7. Now what we're going to do, we are going to multiply, we'll look at the second term here. We are going to multiply the denominator x by 3. So we also have to multiply the second term by 3. And similarly in the first term of the denominator, so this particular term, so we multiply the denominator x by 2 and we have to multiply the entire term by 2. So that gives us limit x approaching 0, 5 plus 3 times 4 is 12. So we have 12 times sine 3x over 3x divided by 2 times 4 is 8. So we have 8 times sine 2x over 2x plus 7. Now when we apply the limit to each of the term in both the numerator and the denominator, we get 5 plus 12. So the limiting value of sine 3x over 3x is going to be 1 divided by 8 times the limiting value of sine 2x over 2x is 1. So plus the remaining term, which is 7. So we have 5 plus 12 is 17 and 8 plus 7 is 15. So 17 over 15 is going to be the limiting value of the given function when x approaches 0. Let us do another problem. So here we have the trigonometric function 7x plus sine 3x divided by sine 2x plus 4x. So we have to find its limiting value when x approaches 0. So like the previous problem, we are going to divide both numerator and the denominator by x. So we have 7x over x, which is going to give us 7, plus sine 3x over x whole divided by sine 2x over x plus 4x over x is going to give us 4. Now we are going to do some manipulation here. So we're going to multiply x with 3. So that means we have to also multiply the entire function sine 3x over x with 3. Then we multiply x with 2 and then multiply x2 to the numerator. So that gives us limit x approaching 0. So what we're going to do, we're going to apply now the limiting value to each of the now we're going to apply the limit to each of the terms in the numerator and the denominator. So for the first term will remain as 7, the second term will be 3 times limiting value of sine 3x over 3x is 1 divided by 2 times the limiting value of sine 2x over 2x is 1 plus 4. So we have 7 plus 3 in the numerator, which is 10, divided by 2 plus 4, which is 6, which can be further reduced down to 5 over 3. So this is the limiting value of the given trigonometric function when x approaches 0. Let us do another one. So here we have the trigonometric function 1 minus cosine of theta divided by 2 theta squared. So we need to find out its limiting value and theta approaches 0. So let us begin by first replacing the numerator. So this is the numerator will be 1 minus cos theta, can be written as 2 times sine squared theta over 2 divided by 2 theta squared. So the 2 and 2 gets cancelled. We have limit theta tending to 0. We have sine theta over 2 divided by theta times sine theta over 2 divided by theta. So we're going to divide theta by 2. So that means we have to multiply by half. Similarly here, we are going to divide theta by 2, and that means we are going to multiply by half. So we have 1/4 of the limit theta tending to 0. So we have sine theta over 2 divided by theta over 2 times the limit theta tending to 0. So we have sine theta over 2 divided by theta over 2. So we have 1/4. So this is going to be the limiting value of the given trigonometric function when theta approaches 0. Let us do another one. So here we have the trigonometric function 1 minus cosine of 2x divided by 3 tan square x. So we need to find its limiting value. So clearly what we can do is we can convert the numerator, which is 1 minus cos 2x, to 2 sine squared x, which will be divided by 3 tan square x. So tan square x can be written as sine squared x over cosine squared x. So that will be simply limit x tending to 0. So we have sine squared x in both the numerator and the denominator. So we have 2/3 of cosine square x. So when we substitute for the value of x, we have cos square 0. So this gives us 2/3. So this is going to be the limiting value of the given function when x approaches 0. So let us do another one. So here in the numerator, we have 1 minus cosine of 4x. We know that 1 minus cosine of 2x is equals to 2 times sine squared x. So that means 1 minus cosine of 4x will be equals to 2 times sine squared 2x. So let us substitute this value into our function. So we have limit x approaching 0. So we have 2 times sine squared 2x divided by x squared, which will be equals to 2 times the limit x tending to 0. We have sine 2x divided by x multiplied by sine 2x over x. So we are going to multiply the denominator by 2, and we have to multiply by 2 to the function. Similarly to the denominator of sine 2x over x, so we multiply by 2, and that means we have to multiply by 2 in the numerator. So that will be equals to 8 times the limiting value of sine 2x over 2x, which is going to be 1 for both the two limits. So we have a limiting value of 8.